Today we are solving problem 1.40, in which we are going to use probability and statistics in order to solve it, as we are going to deal with customers which are going to be chosen randomly in order to make random decisions. So we start by organizing the information that the statement gives us. We have customers that are divided into three groups: very young, college students, and adults. And we are giving the probability of a customer belonging to each of these groups, as well as the probability of each customer of the different groups buying. We have 0.2, 0.6, and 0.8 respectively. So the problematic in A is the the customers that will buy, and that's why we define the variable as the number of customers that make a purchase out of 100. As the result can be buying or not buying, and the number of customers are independent one from another, meaning that the decision of one customer doesn't affect the decision of another, we have a binomial distribution, which probability distribution we can see here, and has the parameters n, which is the number of the sample, in this case 100, and p, which is the probability of success, which in this case is buying, and we are going to calculate. In order to calculate this probability, we need to multiply the probability of a customer belonging to each group by the probability of buying. By doing this, we obtain 0.52. And now the statement asks us to calculate the probability of at least 45 of the customers buying, which is the same as 45 or more customers buying. In order to be able to enter this to our commander, we have to express it as more than 44 customers buying, which gives us this result.
Now we have another problem, which is to calculate the probability that more than 5 college students will enter the store before one of them makes the purchase. So we have to describe a different variable, which is y equal to the number of college students that will enter the store before the first one makes the purchase. As they ask for the first success, which is the first college student making the purchase after 5 students that don't make the purchase, which is the number of failures, we can use a geometric distribution, and the parameter is the probability of college students making the purchase, which is 0.6 because all of them have the same one. So with our commander, we can calculate the probability of y being higher than 5, which is 0.0041.
Now, the problem we have is finding out the probability of the shop having more than 35 customers in one day. We use Poisson distribution since we are referring to a period of time. First of all, we define the new variable u, which means number of customers in a working day, assuming it lasts 8 hours. We have to substitute lambda in the distribution function. For that, we calculate the mean for the whole working day, knowing that for 1 hour is 5. So we got lambda equal to 40. Also Poisson, since the number of customers in 1 hour is independent because the decisions don't affect the customers one the following hour. Finally, we calculate the probability of u being higher than 35 with our commander.
Now we're going to see a conceptual map of the problem we have been dealing with. To start off, we have dealt with random variables. Knowing this, in part A, knowing that the result could be success or failure and that the variable was independent, the distribution was binomial, and the probability distribution used was this one, with parameters n and p. For B, we have been dealing with a number of failures before the first success. This clearly represents a geometric distribution, which probability distribution is as this one and has a parameter p. For C, we know that given time, surface of space, we use a Poisson. In this case, we have been given the time. And so we use this probability distribution with parameter lambda, which is the mean. However, we were given the mean of 1 hour and we needed the mean of 8 hours. And due to the property of the sum of independent Poisson variables is equal to a Poisson variable, we were able to calculate the new lambda.